Today, I'll be talking about my project on a big data NLP sentiment analyzer solution. I historically got my degrees in computer science and chemical engineering from the University of Texas at Austin, where I graduated in the top 5% at the Cockrell School of Engineering. Apart from this, I was also awarded my MBA at the McDonough School of Business at Georgetown University. My MBA was sponsored by my previous employer at the Department of Energy. I bring extensive experience in the realm of embedded system software. I also worked as an embedded system software engineer at Wind River Intel, and I co-founded a UC Berkeley-based embedded system spin-off, which was successfully acquired. This background in system software and my interest in business analytics led me to my capstone project, which is an AWS Elastic cloud-based solution to batch, train, and test an NLP sentiment analyzer on gigabyte scale AWS Amazon Reviews dataset. In order to implement this solution, I created a Pyspark feature pipeline, which takes about 20 million five-star review ratings from the Amazon Reviews dataset. This is an unbalanced dataset. And as a part of the EDA process, the data is cleaned up and a balanced review data set is generated. This is followed by a class generation step where there's an option to create two different class labels, one for a two-class positive, negative, neutral label, and the other option is for a three-class positive, negative, and neutral label classification. This is followed by text featureization with the two different options, which involves bigramming followed by TF-IDF vectorization or a unigram followed by TF-IDF vectorization. Following the step, a feature reduction step is done, whereby the user has the options between a chi-squared feature reduction, minimum document feature reduction, and no feature reduction. This is followed by a Pyspark model pipeline, which uses about 4 machine learning algorithms from the Pyspark machine learning library, and up to 3 parameters could be chosen for each of these models. This gives a total of 144 model combinations and 50,000 features. In order to implement this solution, a dynamically scalable AWS Cloud Architecture was developed. And this is a fully automated object-oriented programming solution whereby a user script is used to create and terminate the cluster. The input data source is from an S3 data store, and the output data is stored in a dynamic DB NoSQL database to enable fast query processing by the user application. The overall AWS EMR cluster contains an EMR master and EMR core nodes. And the EMR master has the Pyspark feature pipeline and the Pyspark models that were mentioned in the previous slide. And the entire process is managed and clusterized using a distributed architecture based on an YAN application and resource manager. This entire solution was implemented predominantly using a Spark, NLTK processing, as well as a host of AWS Cloud engineering tools that you have seen in the last slide. The results, we got 83% precision for the positive class, 77% precision for the negative class, and 36% precision for the neutral class for the 3-class classification case using the best case logistic regression model. And in the 2-class classification case, you got an 86% precision for the positive class and a 76% precision for the negative class, giving an overall accuracy of 81% for the best case logistic regression model. Now, the underperformance of the neutral class could be explained by looking at the average Gini importance in the feature analysis step. And by looking at the top 30 words, which had the highest average Gini importance, we noticed that words like would, which could be interpreted as would not or would have, could be interpreted as both positive or neutral. This makes NLP processing very difficult. As you can see in the 2 sentences, the yellow sentence and the black sentence, It is very hard to distinguish which is positive and which is neutral. I'll leave it as an exercise to you to decide. With this, I'll open up the dais for any questions that you might have. Thank you.